Here's our Chapter 4 activity, page 1. And on page 1 I have two different tables. And you can see that on the bottom table, let X be the number of pets a student has. And for the top table, up here you can see that I said let X be the number of siblings a student has. Both of these are examples of a discrete random variable. Yes, the values of X are discrete. And you might feel like they're not completely random, but if I'm going along and trying to determine whether the next person questioned will have 1 or 2 or 3 siblings, it might seem kind of random. And then there's different probabilities associated with each response. So what I have in the table below is we will calculate the probability of each response. The total of all the probabilities for all the responses needs to be 1. Each of these probabilities needs to be a decimal between 0 and 1. If you think about probabilities, you shouldn't be too shocked. 0 means impossible, 1 means 100% chance. So all of these probabilities going down the table are between 0 and 1. And if you check them, I think they add up to 1, or if they're like 1.01, that's just because of rounding. So let's dig a little deeper into this. Two different discrete random variables. We are going to generate the probabilities from the class survey. So starting out, I actually just had the frequency for each response. So 2 people in the class survey had no siblings, 12 people had 1, 5 people had 2, and so on down the list. The total number of responses was 36, so that's my n. I don't total this. This is just the number of siblings that people reported. And then let me just read this. We generate the probabilities from the class survey. The table with columns X and P of X is called the probability distribution of the random variable. And I will present a cleaned up version of this table on the next page, because right now this looks a little cluttery. We are going to figure out how to find that distribution, and then we'll calculate the mean and standard deviation for both the number of siblings and the number of pets. Now, before you start, which do you think has a higher mean? Do you think the average number of siblings is higher, or is the average number of pets higher? I can't remember the answer, but thinking about it right now, in any random family, do you think there are more siblings, more kids, or more pets? I almost feel like pets are easier to accumulate. You're not going to accumulate siblings as much as you can accumulate pets. So if I had to guess right now, I'd say that the number of pets is higher. And then standard deviation measures the variability of the responses. We'll see. We'll see what we end up with. Let's look at the data down for number of pets. So for number of siblings, we went from 0 through 10. For number of pets, we went 0 through 8. So you might think, oh, there's more variability in siblings, although there's not that many people out here on the fringes, and people are more clustered right in here. Whereas in the pets, maybe we had more variability. So we'll find out on the next page. Let me get rid of that and go back here. So Okay, so that's what I was just talking about. In order to find the probability, so P of x represents the probability of every value x. So the probability that someone has no siblings is 2 out of 36. When we divide 2 divided by 36, I get 0.0555, so I round that off to 0.06. 12 out of 36, 0.33, okay, and so on down the list. So the way we write this formula is we just say frequency divided by n, and that's what we were doing. Now there's another column. This column is x times p of x. So I'm going to take each column 1 entry and multiply it by my p of x entry. Obviously 0 times 0.06 gives me 0. Let's do the next row. 1 times 0.33 gives me 0.33. 2 times 0.14 gives me 0.28. So x times p of x, I write them down in each of these slots, and that completes this column. And now check out this mathematical formula here. This says mu is equal to, and then this sigma notation means the sum of all of the x times p of x values. So all this means is add up all these values. When you total them, you're going to get 3.06. Mu represents the, here we are, this Greek letter mu is mu, and it stands for the mean, and usually mu represents the population mean. So I just explained to you the process of doing this by hand. I can actually have you do this whole process on the calculator, and that's what I'd like to show you next. So I'm going to clear out this screen. I'm going to go into, did I have these instructions on here? I think I did. I'll walk you through the process. So I go into Stat, Edit, and I did want to show you that when you have the old data values, these are the apples, potatoes, and onions, I can arrow up onto the title of the column, press clear, and arrow back down. Arrow over, up, clear, and back down. So this way I get rid of, okay, I accidentally just deleted that. So I need to go up, clear, and back down. And that can get rid of all the data values that I don't need anymore. Clear and back down, over, up, clear, and back down. Okay, I think I'm all cleared out. There are 6 lists available in Stat Edit. So I'm going to enter the data. Arrow over to L2. I'm going to try really hard not to make a typo here. 1501. 301. All right. Now, I want to draw your attention to what I wrote right there. In order to not have to do all of this in a tedious fashion, I arrow over to L3, I arrow up onto L3, and then I press enter, and I can just tell it to do second L2 divided by 36. So it's going to take all of the L2 values and divide by 36, and it gives me the decimals. They're not even rounded, so it's going to be more accurate than what we got on paper. and then I arrow over to L3, L4, over and up, enter, and I want to do L1 times L3. So second L1 times second L3, enter, the whole thing is populated. And you can see that it sort of agrees with what I've got here in this column, but it's a little more accurate. So the remaining challenge is how to add up the values in the column, because I don't want to have to do that by hand. So what I really want is the sum of x, where the x's are the L4 values. So again, this sigma notation just means add them all up. And I know these aren't actually the x's, but I can go to second quit and go to stat calc one variable stats. The list that we're dealing with is L4 this time. We're not going to be doing a frequency list. I just thought of another way to do this, but let's go ahead and do this. I just am trying to total up the values of L4. So calculate, and then the thing that I'm looking for is right here. So the sum of the data values is 3.06, exactly the same as what I got on paper. So that agrees with my results. And I'm gonna quit out of here for now. Another way to do this would be to go to stat calc one variable stats, put in L1 for my list, put in L2 for my frequency list. This would be if I didn't even want to bother doing columns 3 and 4. What if I just gave this information to my calculator? Could it still come up with this result? Yes, it can. So if I go down here to calculate, you'll see that it does calculate the mean. X bar though, it doesn't call it mu, it calls it X bar. So it's treating it like the sample mean, but that's exactly the same number. So there's different levels of calculator intensity. You can be super lazy, just put these two columns into your calculator and get the sample mean and the sample standard deviation. On the next page, I'm going to be showing you the standard deviation, and it is 2.54. So right here, I shouldn't have said sample standard deviation. It's the population standard deviation, and it is 2.54. It's this sigma value right here. That's the sample standard deviation. Ignore it for now. We're dealing with a strictly theoretical population standard deviation. And so on the next page you will see, let's just jump ahead. On the next page you will see sigma is equal to 2.54, mu is equal to 3.06. So it's slightly annoying that it's X bar on your calculator, which I taught you was the sample mean, and mu is actually the population mean. So just go with this, and we can go through that process again for pets, and we'll confirm those two values here. Let me go back up here and just make sure. Okay, so I think I've covered everything for the number of siblings. Let's go down and deal with number of pets. So I'm just going to hit enter. I'm going to go back into stat, edit, edit, enter. And I've only got 2 columns left, so I think I'm going to do the lazy method first. I'm just going to enter these into L1 and L2. I mean L5 and L6. So I'm going to put in 0, 1, 2, 3, 4, and 8. And then the frequencies, 9, 9, 11, 2, 4, and 1. So only one person in the class had 8 pets, 4 people had 4 pets, 2 people had 3 pets, 11 people had 2 pets, and so on. So I don't have any more columns left to continue my process. So I'm just going to do second quit, stat calc, one variable stats, L5, enter. The frequencies are in L6, enter, calculate. And so here I'm looking at X bar is my mu. I'm going to scroll down here. Okay, well that matches what I got here, 1.69 if no rounding. And again, here we get that mu is equal to 1.69, and sure enough, sigma is 1.63. So that agrees with what we get right here. So standard deviation 1.63. We'll talk about that in a second. Now the low-tech version of how to do this is, first of all, to turn the frequency into a probability, 9 divided by 36, 11 divided by 36, and so on, and we write all the decimals down. That is the P of X column. And then we need to make an X times P of X column, where we multiply every X value times its P of X value, and I show that in this column, and then we add all of these up. So again, mu is equal to the sum of X times P of X. If you do round, you get 1.67. If you don't round, you get 1.69. Don't worry too much. If I can see that you've done the correct process, I'm not going to worry about being off a tiny bit. Basically, similar answers.